Picture yourself crawling into an aircraft's fuel tank. You have to carefully squeeze through this hatch that's smaller than your shoulders. Inside, the only light comes from your headlamp as you're surrounded by the smell of jet fuel. You wriggle deeper in as the ribs of the tank cut and scrape at your skin, and the cool air pumped in from the hatch dries your sweat. The heat from the warm skin of the aircraft is just inches from your face as you contort yourself until your hands are free to start working, hoping that you remembered everything you need to bring in and do, because otherwise you'll be making that painful crawl back out all over again. You take some comfort from knowing that just outside the hatch, you've got a wingman there to talk to you and make sure that you're okay. But you have to push aside the knowledge that should you become trapped or suffer a medical emergency, they cannot come in after you. Instead, you'll have to wait for an incident response team, which could take 30 minutes or more. This uncomfortable scenario is a daily reality for hundreds of airmen in our maintenance community, the largest career field in the Air Force. Okay, let's talk regulations. We're the Air Force, we love regulations. According to OSHA and Air Force regulations, a confined space is an enclosed area not designed for habitation with hazards present, such as getting stuck or toxic fumes. Regulations require that people working in these areas be continuously monitored by someone sitting outside doing nothing else except verbally verifying the safety of the person working inside. At Warner Robins Air Logistics Complex alone, airmen spend more than 40,000 hours a year doing confined space work that's critically necessary to get aircraft back in the air and keep them flying. For every space that's entered, there's another airman sitting outside doing nothing else except monitoring the work going on inside. That adds up to nearly another 40,000 hours a year of labor. The Air Force does this type of work very safely, but it is costly and time-consuming. You might be thinking, we must have robots or maybe some remote-controlled means of doing this work. But we don't. The fact is, robots can't handle it. It takes the strength, flexibility, endurance, perceptive skills, and intelligence that only a human can provide in a compact enough package. The need for airmen to do this type of work isn't going away, but we can make it better. And it won't require inventing a lot of new technology. We just have to reinvent how we use a few ordinary pieces of technology that we usually take for granted. A few years ago, an engineer was working on a major upgrade to the C-5 cargo and transport plane that required long hours of confined space work inside the aircraft structure. This engineer happened to visit a family member in the hospital and saw that the nurse's station had a screen which displayed all the vital signs for the patients in the ward in one place, with a few flashing that action was required. Now, there are big differences between a hospital ward and an aircraft maintenance facility, but this engineer had a spark of innovation. What if instead of sitting outside a hatch monitoring, we could monitor all of the work remotely? Instead of yelling back and forth, we could use radios. Instead of just saying, "I'm okay," we could monitor vital signs. Instead of checking that the air is safe to breathe once before we go in, we could monitor it continuously right around the worker. Turning that spark of inspiration into a reality is where my team came in. In translating hospital technology to confined space maintenance, our team of scientists and engineers saw some obvious problems. Big monitoring boxes, lots of wires running everywhere, nurses and techs to put electrodes on and replace them, not compatible with unheated aircraft hangars and getting into and out of very tight spaces. But what could work? You might not think of a smartphone as a maintenance tool or an athletic heart rate monitor as a safety device. But after a lot of trial and error, our team put these together with software and the right procedures to develop an inexpensive means for freeing up labor to get aircraft back to flying faster. Our first idea for vital signs monitoring was to use chest band heart rate monitors, the kind of thing many people use to do zone exercise. They're cheap, easy to use, and durable. That idea lasted about 5 minutes after we had someone wear one while crawling into a fuel tank. As soon as they were inside the hatch, it was down around their waist and no longer functional. Next, we tried a shirt that had the electronics in the middle of the chest. Very Iron Man, Kenneth. Very cool. Except when you lie down to crawl into the space, that pushes the button on the front and turns it off. We tried a device that was attached with an adhesive patch, which worked really well, right up until you start sweating, and it falls off. Remember what I said about the difficulty of getting into these spaces? Finally, we found a shirt that was originally designed for professional athletes. It's a compression shirt that holds heart rate, motion, and respiration sensors tightly against your skin, with a smooth exterior that doesn't get snagged, and lightweight, breathable fabric that's comfortable even in Georgia in the summer. Smartphones work well as a data and communications hub. With Wi-Fi, Bluetooth, and processing power, they're great at pulling together data from multiple devices. But carrying a smartphone into a confined space means just another piece of equipment that could get dropped or wedged somewhere. So we left the smartphones right outside the confined space and instead used smartwatches for communications and user interface, something that was attached, accessible, and available that enables you to call for help or simply ask for a tool. We bought a number of examples of current smartwatches and had someone wear one while going into a confined space. The band broke in about 10 minutes. So we designed an armband holder that was much more rugged. That broke after about 10 minutes. We redesigned the armband holder and came up with a 3D printed holder that's smooth on the outside. It lets you press all the buttons, and it holds up to extended, heavy use. With all of our creative use of existing technology, you also have to recognize when you've got a problem that really does require you to come up with something new. To ensure that the air is safe to breathe, maintainers currently take a sample just inside the hatch once prior to entry. To make that easier and safer, our team developed miniaturized wearable sensors like this one that can continuously monitor for oxygen and explosive gases right where the worker is, and then send that data wirelessly back outside the space. All of this iteration and learning takes time, so much time, and the right environment to test it in. So how do you conduct realistic testing of a maintenance monitoring system? The reserve squadron at Wright Pat quit taking my calls after I kept asking to go diving into their fuel tanks, and the museum didn't trust me to go crawling around inside their historic artifacts. After a whole lot of calls and emails, we found a set of C-130 wings at Warner Robins that had been removed at the end of their service life and were destined for the scrapyard. After some more calls and emails, I filled out a shipping requisition form, sent it in, and was told I'd get a call when the wings left Warner Robins on their way to Dayton. That call didn't come, and I went on leave with my family in a remote area with minimal cell phone service. I got back into service, and hey, what do you know? A driver who'd never been to Wright Pat before showed up at the main gate with no base access and a flatbed load of C-130 wings, wanting to know where he could drop them off. A couple of my colleagues really stepped up for me and got it sorted, including jumping up in the cab with the driver to get him through the gate. And by the time I got home a couple of days later, I was the proud owner of a set of C-130 wings sitting in the parking lot outside of our building. A couple of months later, we had one of them installed indoors as a dedicated test stand that enabled us to break many more watch bands without interfering with actual maintenance. The system has matured to the point that we've tested it at squadron scale in actual maintenance. That validated that we can reduce the labor required for safety monitoring by 80%, or 32,000 hours a year at Warner Robins alone. Those safety monitors are all maintainers themselves, who would almost always rather be working than watching someone else. So that labor goes right back into getting aircraft back in the air faster without compromising worker safety. Since our last test, the team has supported the launch of a new company created just to market and sustain this system. We closed out the AFRL project earlier this year with a COVID-compliant remote demonstration of our remote monitoring system. I was hoping for a large-scale in-person demonstration, but by going virtual, we enabled well over 100 people to attend and see live real-time monitoring of maintainers and team members spread across 5 states, from California to Georgia. Though we've closed out the AFRL work, the project and the team continues, establishing the relationships with other industries to enable them to use the system and achieve Air Force levels of safety at a very affordable cost. I look forward to seeing the system in use with municipal sewer workers, construction, and agricultural workers. The US alone suffers more than 100 deaths per year in confined space work in these industries. In the course of, if we could save even a fraction of those lives, that would justify everything that our team has done. In the course of doing this work, I've watched airmen come out of aircraft, bloody and bruised, drenched in fuel and sweat. They are nevertheless deeply proud of the work that they do and grateful for our efforts to make it just a bit better, and all with a smartphone, some athletic gear, an idea we borrowed from the hospital, but most importantly, a team of very dedicated people who saw things not as they are, but as they could be.